I'm Guillermo Valenzuela. I'm part of the environmental sustainability team. I'm energy system modeler and participate from the first phase of the AtLAST in designing this renewable energy system for the new telescope, and also participate in the how to include the social aspect in this project. And yeah, and also here we have Paola Velasco. You can maybe introduce yourself.
Yeah, hello everyone. My name is Paola Velasco. I'm a postdoctoral researcher also at the University of Oslo. And my background is on sociology and economic philosophy. And I mainly work at how is it that we engage communities and the public in general in the production of renewable energy. So this is how I get connected to the project itself.
Super. Thank you, Paola. So we're gonna start. So the first thing thank you for attending to this talk and for listening to us. The thing is, we will move a bit away from the kind of usual talk maybe about astronomy, and we will talk about the other aspect that is coming from the sustainability of the project. And for example, we will talk about today about the role of astronomy in reaching this sustainability in the area, and how can contribute the astronomy's community in that. And also we will talk about the experience that we have from the first phase of AtLAST. So for the first part, probably as all know that AtLAST will be located in the north of Chile, in the region of Antofagasta, in the middle of the Atacama Desert, in a part called Chajnantor Plateau, in the eastern part of the region. Here is the region, and this is the place where will be located AtLAST. This area is characterized by to host or to be one of the best places for astronomical observation. Actually, it's a hot spot for astronomical observation and hosting around 10 other telescope in the area. This place is at 5,000 meters above the sea level, but now the question is why we are talking about sustainability in AtLAST. Yeah, why is important for astronomy or for this telescope, the sustainability, to have this sustainability perspective? To answer this question, we need to understand that this place is located in a remote area. So that means that, as I told you, is at 5,000 meters above the sea level, but also is far away from the national grid. So all these telescopes here are connected to their own natural gas and diesel generator, producing around 18 to 24 kilotons of CO2 per year. That is a lot in this area because there's no other source of emission in that add to the impact the environmental side. And in that sense, AtLAST, I mean, this place, as you can see, is in the middle of the Atacama Desert, but and beside to be one of the hotspots for astronomical observation, it's also a good place for solar radiation. So it's one of the prime spots for solar generation. For example, for solar generation, we can see here that the solar irradiance here in this place in the Chajnantor Plateau, it's almost constant during all the year. Here you can see the radiation during, along a year, and all the time where is the radiation during every day. It's almost constant during a year. And if we compare, of course, it's a bit unfair because here is Norway. So of course, there's not a lot of sun in this place, but you can see that it's the profile in the radiation is totally different, and in comparing this, you can see that it's almost constant during the whole year, even during winter in the South American winter. I mean, during July, June, and August, its content, except of course for some days in July or maybe also in February. So having this context, we AtLAST, as Claudia mentioned in the beginning, is one of the main goals of AtLAST is to be the first telescope to consider renewable energy source from the beginning, from the design phase, and particularly solar. As you can see that the radiation is very good in this area. In that sense, we did in the first phase, we did a lot of work to design a renewable energy system for the telescope and covering different aspects of the sustainability. On one side, we cover for example, the economic and the environmental aspects. We took a system approach where we designed different alternatives that can supply electricity to the telescope, and then we determined the best alternative for the system in terms of cost or other aspect. We consider different assumption behind. For example, that the wind generation is not possible due to some interference that can be generated to the telescope. And also we consider different sites where we can install the renewable energy system, and there is no transmission line. That's another aspect. We then evaluate the system, this renewable energy system, from different perspectives. One is the techno-economical, doing a techno-economical optimization, so covering the economic aspect of the sustainability. And also we consider the life cycle assessment of the renewable energy system, covering the environmental aspect. Then, since we have these two different dimensions or different perspective of the system or focus of the system, we consider to do both evaluation at the same time, considering the multi-objective optimization and evaluating both systems and studying the trade-off between both aspects. As I told you, we did a lot of work, and all this you can see in this publication, and also you can visit the web page of AtLAST to see more, to learn more about this, what we did in this part. But here you can see an empty space here that if you remember, we are trying to evaluate the renewable energy system from the sustainability perspective. That's considered economic, environmental, but also social. And that part is missing in at least in all these evaluation that we did. But also something that I didn't told you in the beginning was, in addition to be one of the first telescope to consider the energy sources in the design phase, also consider to explore options to incorporate the nearby communities in the evaluation to the system. So in that sense, the renewable energy system for AtLAST can also contribute to the local community in this area. So and then we can cover this dimension of the sustainability and cover the three of them at the same time. The first part. So how we included the nearby communities. To do that, we need to back to this map. I have repeated this slide a lot of time in the presentation, but is to understand the context where is located the telescope, and also how AtLAST can contribute to the sustainability of all the sector. So here we have the 10 telescope. I told you that is a remote area. It's located at 5,000 meters above the sea level, but also there is a small community, or not a small, it's a small city, a town, located 40 kilometers away from the telescope at 2,500 meters above the sea level. That is the town of San Pedro de Atacama. This town have exactly the same issue, the same challenge that the telescope. They are not connected to the national grid, so they have they have their own electricity provider that generate the electricity based on diesel generator. And in addition to that, We can talk about the San Pedro Atacama, the population is around 11,000 inhabitants, and they have a floating population of 14,000 people. That is mainly tourists that visit this place. That is almost doubling or mostly doubling the electricity demand in that for the normal inhabitant in the city. And also they have, as I told you, they are not connected with to the national grid, and there's many small communities around the San Pedro that are not connected to even to the local provider, and they don't have access to electricity. They suffer also for a high electricity price and some power outage due to this increase of the people that are visiting the city. So as I told you, and at the same time, for example, that the telescope generates a lot of emission in the area due to the use of diesel generator or natural gas generator. San Pedro use their own local provider that is called CESPA, and they also are based on our power provide electricity using diesel and natural gas generator, generating around 9 to 12 kilotons of CO2 per year. In that sense, we with this part of to cover the social aspect of the project, we try to answer this question: how can this energy system of focus on for AtLAST can be also be renewable based and inclusive at the same time? In other words, we want to incorporate the technical performance and the social preference of the people in the evaluation of these different energy scenarios, this energy approach that we talk about. We did this work together with another European project called Renaissance, who helped us to implement some workshop and so also to design some survey to distribute to the stakeholders. We use a multi-actor, multi-criteria analysis, or MAMCA. It's a methodology where the idea is to incorporate the opinion of the people in the design of the system and then discuss the result in the last part through some workshops. We identify the stakeholder in the area, that the main actors here are San Pedro Atacama, the municipality of San Pedro, the local energy provider, and the observatories, these four main stakeholders. Then we share a survey asking about the preference of a renewable energy system, talk about the criteria that they want to consider in a system. And that we discovered that here you can see a table with the value from 0 to 1, meaning that 1 is the more preferred criteria. And we discovered one interesting thing, that, for example, for contrary to, opposite to what we expected, not more people care about the landscape impact. That is something that at least when I saw the result was surprised me, because I expected that people, one of the main preference of the people in terms of renewable energy, for a renewable energy system, will be the landscape impact. But no, only observatories as show some preference for this criteria. Also, we discovered that for the local provider, one of the more the preference of the criteria is the reduction of emissions here. So they obtained 0.6. And also for the municipality and for the resident, one of the most important criteria were the energy efficiency and the replicability, because they want to also have the same idea of this renewable energy system, but for other communities around that they don't have access to electricity. We also through this survey, we discovered some challenge. We find out some found out some challenge. For example, the lack of collaboration between the different stakeholders, different actors in this place. And also they're respecting indigenous land and the long distance. That is due to mainly due to the installation of the distribution lines. I told you, for example, from the telescope to San Pedro, there is 40 kilometers distance. Then, with this information, we define some energy scenarios where we have different alternatives to provide to the electricity to the telescope, but at the same time, we define some alternative can provide electricity to the community of San Pedro. That is, for example, we call non-cooperative scenario, where the community of San Pedro is not considered be powered by the AtLAST renewable energy system, and the cooperative scenario that is where is included. We cost optimize this solution, and we get, of course, that the cheapest alternative is the hybrid energy system. That is a non-cooperative scenario, but if we go to the sharing surplus of energy system here, we can see that we can have a system that where the cost compared to the actual solution, that is the diesel that is here, can be reduced, and at the same time can provide electricity to San Pedro Atacama. Here is the electricity demand of San Pedro when it's covered with CESPA, that is the current situation, is represented by in orange bars. And here in this cooperative scenario are reduced around 60% of the total demand. So that means that the renewable energy system for AtLAST can supply electricity to San Pedro, and at the same time can reduce the emission in this two scenario. Then we present this result to the community, to the stakeholder. We have two main workshops with them, and we discuss which alternative of these 4 or 5 before what are the most preferred for them. For most of the stakeholder, they like the cooperative scenario, particularly the sharing surplus of energy, because it reduces, as I told you, reduce the CO2 emission and also the electricity cost. However, for the observatory, was a bit different, yeah, because they prefer the non-cooperative scenario, the hybrid energy system, and this cooperative scenario was the second one, the second that they prefer. They selected this one, the hybrid energy system, because they have diesel generation as a backup, and also because it was the cheapest solution, as I told you, and can reduce at the same time the direct emission generated by the renewable energy system. We also do some work in this part, and all the details of this workshop and all the methodology. You can visit the paper that we wrote. But yeah, that is we cover with we try to cover the 3 dimension of the sustainability of the renewable energy system in terms of sustainability, covering the economic, environmental, and social. And in that sense, we explore the option to incorporate a nearby community in this social aspect. But then we ask ourselves, why we don't want, why not go further than this point? Why not to study the role of the astronomy in this part? Or what is the role of the astronomy in achieving the sustainability? And that is part because in that moment also joined the Paola to the team and help us to discuss from the social perspective all this topic.
Yeah, so this is when I came in and I thought, okay, like this is super interesting what you've done. And at the same time, it's also true that when you also implement kind of like energy production sites, we have also seen that there's been growing opposition in different places in the world. So in a way, looking at the social dimensions of installing this new energy systems, then becomes quite important, because of course you want to do good, right? Like this is a good intention to help the community of San Pedro de Atacama to have cheaper electricity. So therefore, we then wrote a chapter to then kind of like have another lens to the plans, and see to what extent they could also contribute to social justice. So therefore, the question, how is it that these new production system can contribute to justice? Next one, Guillermo, and next one, please. So why should astronomy look into the social aspects of implementing, for example, a renewable energy systems to power off-grid telescopes? Next, if you can keep going. So it's very important to know that scientific activities, of course, not only astronomy, but astronomy definitely have an elevated contribution to global greenhouse emissions. For example, in 2020, the average emissions of astronomers based in Australia were estimated at 30,000 CO2 tons per year, which is actually 2 times higher than the annual average emissions of an average Australian. And this can also be compared, for example, for the annual average per capita emissions of India, which in this case would be, this is actually 19 times higher. They only emit about 1,900 tons per year. So, and also the upcoming transition to renewables also follow the social dynamics of existing tensions within the global South divide. So, for example, we're leading astronomical facilities operate in more than 10 countries in the African continent, with more projected observatories on the way. However, this has not necessarily been accompanied by, for example, increasing development opportunities for these communities, particularly in areas, for example, as employment. For example, it's very common to have foreign engineers coming into these facilities as opposed to training locals. So there has been some notable exemptions of this. There has been some training opportunities. However, there's still a big north-south inequalities in research activities. Of course, not only in astronomy, but other areas too. So how is it that we can look, therefore, at these kind of like justices and injustices? And we thought that maybe energy justice could be a really useful framework to look at these, and then also, therefore, to look at some solutions, right? Some policy implications that could be introduced. So basically, energy justice has become a quite useful framework in the context of low carbon transitions to look at, how is it that this introduction of these new technologies, activities, etc., can affect people in different ways. So there's different frameworks to look at energy justice, but the most famous one is the triumvirate one. And basically what it says is it starts with the idea of distributive justice, basically the most basic idea of justice, right? Who gets the benefits, who gets the burdens, kind of like looking at outcomes and who gets these outcomes and how and also the distribution of responsibilities as well. And then, so they thought that this would be not enough. So they introduced the idea of procedural justice. So which is kind of like, so to understand why there's maybe an unjust outcome, we could then look back and see how is it that the process of decision-making was who participated, how is it that they participated, etc., so that we could then understand the outcomes and maybe do different things to get different results, right? And then the last one would be recognition justice. So it's this idea that, when you were in processes of decision making, That doesn't necessarily mean, particularly when you're trying to include as many people as possible, you realize that there's some people that have more power than others, some people that talk more in meetings, some people that remain silent, some people that don't even attend public deliberation spaces. And these can be because of social identities, right? That build our identities in terms of gender, sexuality, race, and ethnicity. And looking at these different identities will be very, very important to then improve decision-making processes so that we could get better outcomes. So this is kind of like the idea. So we're going to use this framework to then look at the initiative of AtLAST telescope and see to what extent it can contribute to justices. So in terms of distributive justice, so definitely contributing with more energy would not only decrease the energy vulnerability of San Pedro de Atacama, because of course because they would contribute to increasing the security of the supply of energy, but also it might mean that it might reduce the costs of energy, which right now, as Guillermo said, it's the cost of energy in these places is much higher than the Chilean average. And at the same time, these benefit sharing can go two ways. So in a way, the telescope can actually also benefit from this arrangement, because San Pedro de Atacama can also offer demand side management. So basically, try to use more energy during sunny hours, which may reduce operating costs for the telescope itself and optimize energy use. And also, these could add additional flexibility to counter the intermittent power supply from the photovoltaic plant, which will be very, very important to achieve this security supply of the AtLAST telescope, which, of course, as astronomers know, if there's an outage, that would be awful. And then in terms of procedural justice, the integration of this renewable energy system could become an opportunity to include the community of San Pedro de Atacama in decision-making about processes of design and operation of the system itself, which can contribute to procedural fairness, particularly, for example, this could be through the MAMCA method that Guillermo showed us. However, of course, there's many roadblocks that remain. He mentioned some of them. I'm going to mention some others. If you can continue to the next slide. So yes, different ontologies, financial resources, political interests, and power imbalances make this ideal win-win scenario a bit difficult. So one of them is the idea of introducing benefit sharing only comes as kind of like an afterthought when, again, in general, in scientific activities, and not only here. However, it's interesting because by including this social dimension, then we realize how important this social dimension is, and then it becomes more prominent in even, for example, in the case of the first AtLAST project. It was more about the economic and kind of like more economic and environmental sustainability, and then looked a little bit at the social. And now in this second project, there is one big part of one work package that is really focused on how is it that this telescope can also look at kind of like regional social fairness as part of their operations. So in a way, it's great that even so it's becoming an afterthought. It was an afterthought, but now it's becoming more central. And the second thing is that well, yes, who will take the responsibility of paying for a 12-kilometer transition line that would be required, right? And who would pay for the maintenance and costs of it? And of course, the third question is who gets cheaper electricity, right? Because San Pedro de Atacama is, as you know, in need of cheaper electricity and secure energy supply, but other communities next to it also need it. So who then gets this electricity is very important. And then finally, so what are some of the policy recommendations that we kind of like came to thought through these process of reflecting on energy justice? And we realized that, yes, we global researchers in the global north should reflect more and act upon shared responsibilities to actively contribute to the well-being of the communities where we do our research. And ideally, these actions should be in line with distributive justice in terms of accountability, but also how is it that we can take care of future generations, right? So some of the things that could be done is, yes, is it possible to offer some training to community residents uh, through, for example, engineering internships, other kinds of trainings in topics such as coding on our energy systems, so that they could possibly maybe get jobs in this new initiative, or maybe also work in new local industries related to telescopes. And then the other one is maybe AtLAST, the AtLAST project can define an inclusive decision-making scheme or at the planning stage of this new electricity system, so that it can also avoid top-down decisions from the electricity provider, CESPA, for example, because right now it's quite prominent how is it that they can kind of like control how is it that electricity is supplied in the community itself. So therefore, how is it that we can place justice at the center of these future actions, any future actions? So we believe, as the last slide, last of my slides, is that we feel that there's two ways in which AtLAST is contributing to this justice agenda. One of them is adding the social understanding of decentralized energy configurations, such as demand-side management to energy systems, which can has the potential to increase affordability and reliability of electricity supply to remote areas, such as in the case of the Atacama Desert. And also by using, we believe that we're using astronomy as a case study of energy justice, findings can become a nuanced example of how scientific research activities can benefit from local carbon energy transitions, such as reducing their costs and optimizing energy use, but at the same time contribute to the recognition of the voice and responsibilities towards communities where we do research. And Guillermo will finish with some questions for you, the audience.
Yes, just to close the session, just to talk about the future step of this work, because as I told you, yes, we realized that astronomy can contribute to from the astronomy we can contribute to the sustainability of the place, but also we did all this work from a local perspective. All this work was from San Pedro Atacama, all the observatories there, the local provider. But we realized that this reality is also happening in other parts of the Antofagasta region, because the Atacama Desert is, as I told you, is one of the prime spot for for telescope. But for example, there are some issues with interfering with the development of the telescope, but at the same time, the development of the region, the Fresnel region. For example, this issue with the power plant that will be located in the next to the telescope can interfere with the observation of the space of the universe, or with this telescope, the very large telescope in the region. So we can continue in this line, and we want to how to say it here is we can contribute how we can contribute to understanding the regional tension, all these problems that are present in Antofagasta, or also maybe in other region, as a new telescope addressing this issue. Or how can we ensure that AtLAST can contribute to the development of Antofagasta at the same time? And so that is our kind of final question that we want to answer. And of course, we don't have an answer for this, but we will try to figure out during this new phase of the project. And I think that's our presentation